Hi, welcome to another video. So there is a new open coding agent model on Hugging Face, and this one is actually pretty interesting. It is called Omnicoder 9B. Now on paper, this may just sound like another random open source coding model release, but I think the angle here is a little different. This is not being pitched as just a code completion model or just another instruct model with some coding sprinkled on top. Teslate is positioning this as a real coding agent model, and they say that it has been fine-tuned on more than 425,000 curated agentic coding trajectories, and not just any trajectories. According to the model card, the data was built from successful runs and reasoning traces coming from models like Claude Opus 4.6, GPT 5.4, GPT 5.3, Codex, and Gemini 3.1 Pro across scaffolds like Claude Code, Open Code, Codex, and Droid. So if you think about it, the pitch is basically this. Can you compress some of that frontier coding agent behavior into a 9 billion parameter open model that people can actually run themselves? And if that works even somewhat well, this is amazing for sure. Now, let me tell you what the base of this model actually is. Omnicoder 9B is built on top of QN359B, and they specifically mention the hybrid architecture with gated delta networks mixed with standard attention. In simple terms, it is trying to keep the model relatively small while still handling longer contexts in a more efficient way. They also claim a native context length of 262,000 tokens and say it can extend beyond that, which is pretty wild for a 9B model. There is also support for thinking mode with think tags, and the weights are Apache 2.0 licensed, which is really important because let's be honest, a lot of the really good coding models these days are either closed, expensive, rate limited, or they can just rug pull features whenever they want. So whenever I see something that is actually open, downloadable, and permissively licensed, I instantly pay attention. And this one also has gguf files available, which means you can run quantized versions locally through llama.cpp. They also give examples for transformers and VLLM, so from a usability standpoint, this is not one of those model releases where they just drop some weights and disappear. They are at least showing you how to actually use it. Now, what is the actual value proposition here? I think it is not the raw benchmark flex. I think it is the idea that this model supposedly learned coding agent habits instead of just coding syntax. For example, the model card says it learned read before write behavior, that it can respond to LSP diagnostics, and that it prefers minimal diffs instead of rewriting everything. And if you use AI coding tools a lot, you know exactly why this matters. One of the most annoying things with weaker models is that they don't edit carefully. They panic, rewrite whole files, ignore the existing code style, break imports, and then act confident about it. So if Omnicoder actually learned those more disciplined agent patterns, then that is a really good direction. Now let's talk about the benchmarks, because this is where I think you should be a little excited but also a little skeptical. On the Hugging Face page, Teslate reports 83.8% on GPQA Diamond Pass at Thwern, compared to 81.7% for the QN359B base model. They also report 86.4% on GPQA Diamond Pass at 3, and 90% on AIM 2025 Pass at 5. So those numbers do sound impressive, especially for a 9B model, but the one that matters more to me is Terminal Bench 2.0, because that is at least closer to the kind of agentic workflow people actually care about. There, the main benchmark table shows Omnicoder 9B at 23.6%, while QN359B is at 14.6%. So that is a pretty decent jump over the base model, around 61% better if you go by the improvement they mention, which is good. But it is also still below GLM 4.7 on that same table, which is listed at 33.4, and also below Claude Haiku 4.5, which is listed at 27. So no, this is not some magical tiny model that is suddenly destroying every frontier system out there. At least the posted numbers do not show that. And there is one more thing that I noticed, which is a bit weird. In the main benchmark section, there's terminal bench, which is written as 23.6, but in the evaluation metadata on the same Hugging Face page, the pass rate is shown as 28.1. Now, maybe there is some explanation for that. Maybe it is a different run. Maybe the page metadata updated later. Maybe one is older than the other. But if you see mismatched benchmark numbers on the same page, take it with a grain of salt. I am not saying the model is bad. I am saying self-reported benchmark numbers are not the same thing as independent testing. And especially for coding agents, the stuff that matters is not just a score. It is whether the model can open the right file, understand the task, make a clean edit, recover when it fails, and not trash your repo in the process. That is why I actually think the training story here is more interesting than the leaderboard story. Because if this model really was trained on successful agent trajectories from frontier systems, then it may end up feeling smarter in an editor than a typical 9B model, even if the benchmark charts do not look revolutionary. And honestly, that is the kind of thing I want more open models to focus on. Less benchmark worship, more actual repo behavior. Now, there are some limitations mentioned as well. They specifically say that non-English performance has not been extensively evaluated. They also mention that tool calling format is flexible, but it works best with scaffolding patterns similar to the ones seen during training. So, if you're expecting perfect results in every setup, I would not do that. If your workflow looks somewhat similar to Claude Code, Open Code, or those kinds of tools, then this might be where it shines the most. And this is also why I think Omnicoder 9B is a really good option for tinkerers, students, and open source people who want a local coding agent base without paying monthly subscription tax. A 9B model is just way more realistic to run than a 70B or 120B monster. And because there is already a GGUF version, this is something you can actually experiment with on consumer hardware instead of just admiring from a distance. Personally, I like this release a lot more than most open coding model announcements, because there is at least a clear thesis behind it. They are not just saying, here's another coder model. They are saying, here's a smaller model that learned from high-quality coding agent traces and tries to behave like an actual software engineering assistant. That is a much better story. Now, is it perfect? No. Do I think the Hugging Face page alone proves that this is the best open coding agent? Also no. I would still want to see more independent evals, real repo tests, bug-fixing tests, terminal workflows, and long horizon tasks before making any huge claims. And I would especially like to see consistent benchmark reporting first. But if you want something open, permissively licensed, relatively small, and clearly optimized for agent-style coding instead of just autocomplete, this is a really good model to watch. And if you're already using local tools with transformers, VLLM, or llama.cpp, then trying this out is kind of a no-brainer. So my overall take is simple. Omnicoder 9B looks genuinely promising. The idea behind it is smart, the open weight part is amazing, and the local deployment options are pretty great. But the benchmarks are still self-reported. There is at least one inconsistency on the page, and I would not crown it the king just yet. Still, overall, it's pretty cool. Please share your thoughts below and subscribe to the channel. I'll see you in the next video. Until then, bye.